Hi everyone. Today I'm gonna go through November 2014 question 2. This question is related to the organic structures, functional group, and IUPAC names, as well as isomers. So the question goes as, consider the organic compounds represented by the letters A to F in the table below. Now let us go through each and every of these compounds and see what they are looking like. Compound A ends with ane suffix, so this belongs to alkane family. It is an alkane. Compound B ends with CHO. This is usually the way we show for the formyl group. That should be a formyl group, so that this is a, let me make this nice. This is a formyl group. So this one is an aldehyde. When we come to compound C, we have all carbon and hydrogen atoms with 2 halogen atoms. So compound C belongs to haloalkane. Compound C is a polymer. It is not part of the syllabus anymore, but this was a question. I'm just saying it. It's a polymer. Compound E is also a polymer. Polymers are the organic compounds which have repeating structures. Look at here, it states N. That means we have N number of each molecules repeating each other. But as I mentioned, polymers are not in the part, it's not in the syllabus anymore, so we don't need to worry for the polymers. When we come to compound F, it ends with on, so this compound belongs to ketones. So here we have all these compounds. The question 2.1, write down the letters that represents the following: an aldehyde. An aldehyde is the compound B. Condensation polymer. As I said, with compound T and E are polymer. I'm answering this question, but you don't need to study those sections. Condensation polymer is answer E. A compound which is a carbonyl group bonded to 2 carbon atoms as its functional group. Both aldehyde and ketone have this carbonyl group, carbon double bonded oxygen, but the difference in an aldehyde, there is at least 1 hydrogen atom on one side. But when we come to ketones, there is no hydrogen around this carbonyl. It has to be 2 other carbon atoms. So a compound which has a carbonyl group bonded to 2 carbon atoms as its functional group is the compound F. That is question 2.1. If we move down, let me erase all those. If we move down a little bit, the 2.2 says, write down the IUPAC name of compound C. Compound C is here. We need to choose the longest chain first, and longest chain will be that straight chain with how many? 1, 2, 3, 4, 5 carbon atoms. Here, when we look at the substituents, I have a methyl group, a chlorine atom, and a bromine atom. The order will be bromine, chlorine, and the methyl group. Bromo, chloro, methyl group. As you see there at the middle, if you start from left, it's going to be 2, 3, 4. If you start from right, it's going to be 2, 3, 4. They're at the middle. However, you mustn't start from left side because of the alphabetical order. As BR, closer to the right side, we better start from the right side. So it goes 1, 2, 3, 4, and the 5. So this compound gonna be 2-bromo, 3-chloro, 4-methyl, and the longest chain has 5 carbon. This is a haloalkane, so we will use ane suffix. 4-methyl pentane. That's the name. And the monomer of compound D. Compound D, we said, is a polymer. It's made of ethene molecules. The ethene molecules come together. They form a repeating structure, and we call it polyethene. The monomer of a polyethene is the ethene molecule. And then the next one is write down structural formula of compound A and F. Okay, structural formula of compound A and F. A is an alkane, so let us write its structural formula. In compound A, we have 6 carbon atoms, hexane. So I need to write 6 carbon atoms repeating each other. 1, 2, 3, or I think it's better I use more space. We will need more space, I guess. I'm just, I can use this. Right, let me turn off the video so I can use this part. Okay, for compound A, 6 carbon atom, 1, 2, 3, 4, 5, and 6. I have methyl groups, 3 of them, on the second, on the 4th carbon atom. Here I have a methyl group. So here I write CH3. And then I have another methyl group on the same carbon atom. And I have the 3rd methyl group on the 4th carbon atom. So here we go. The 4th one is here. So now I have all my substituents written. The rest just add the hydrogen atoms to make the compound stable. Here you mustn't forget to add these hydrogen atoms, otherwise you will lose mark. So here we go. This one needs 1 more hydrogen, that one needs 2, and the last carbon atom needs 3 hydrogen atoms. So here we go. This is 2,2,4 trimethyl hexane. And this is a 2-mark question. If you write 6 carbon atom with the substituents, you get the mark. And when you add everything, all the hydrogens and everything, you get the 2nd mark. When we come to compound F is a ketone with 5 carbons. So let me write 5 carbon, 1, 2, 3, 4, and 5. I have the functional group on the 2nd carbon. So here we go, the carbonyl group. The rest is just adding the hydrogen atoms. 3 goes to the 1st one. 2nd carbon has already 4 bonds. 2 here, 2 here, and 3 to the last carbon atom. That is pentan 2-on. In this case, write in the structural formula. Let me show you like that. If you write the structural formula like that, you get a mark. With the correct full structure, you get the 2nd mark. That is question 2.3. When we go to the next question, question 2.4, the table contains compounds which are functional isomers. Define the term functional isomer. A functional isomer is an organic compound with same molecular formula. Let me change the color. Same molecular formula, but different structural, different type of functional group. So the organic compounds with same molecular formula, but different type of functional group are called functional isomers. And the last question, write down the letters that represent two compounds that are functional isomers. Remember, functional isomers possible between aldehyde and ketone, as well as ester and carboxylic acid. In this table, we don't have any carboxylic acid or an ester. We have aldehyde and the ketone. And when we look at this aldehyde and ketone, compound B has 2, 4, 5 carbon. Compound F as a ketone has 5 carbon. So the correct answer is B and F. These are the functional isomers. All right, that's all for this question, guys. I'll see you another time. Thank you for watching. Bye-bye.